Alright, so you're going to get asked in the test about using something called the discriminant, okay, which is a new word for us. And it doesn't actually give you the answer to a question. What it does is it gives you the sorts of answers that you should anticipate getting. So you might get a question like the first one on the sheet in front of you that says use the discriminant to determine the number and type of solutions to the following quadratics. And the discriminant comes from the quadratic formula. So it goes back to that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. But the discriminant only talks about this section here, okay? So it's what goes underneath the square root symbol. So basically what we do is we just hijack that section of the formula and we just use b squared, which we should write as this, minus 4 times a times c, okay? You can just write neatly like I've done in the formula if you'd like, but this is the preferred one for methods. Now, there are 4 possible outcomes to this sort of question, and this is about whether or not the number's a rational or an irrational number. So we've sort of been learning last year and extended it in this one that there's basically 2 sorts of numbers. There's irrational numbers, and they're things like the square root of 2 that's got heaps and heaps of decimals, or maybe pi is another good example of that. And then you've got nice rational numbers, okay? And they are ones like if you got the answer the square root of 16, because we know that would be a nice round 4, or it might be, you know, 9 halves, something like that, a nice round. Do you remember these from last year with extended? So all of these numbers are what we call real numbers, okay? And they're the ones that we deal with here in maths. Sitting outside of this are what's called unreal numbers. Now we don't have to worry too much about these. What we'd answer these in your test is as no solution, okay? So what I'm talking about when I talk about no solution would be something like the square root of, would be like the square root of minus 3 or any other negative number or something along those lines, something that doesn't have a solution. Does that sound good to everybody? All right, so if we start just picking some examples of some quadratics, we'll have a look at what the 4 different possible outcomes might be. So if we pick, say, x squared minus 7x plus 1, they all have to equal 0, okay? If it doesn't equal 0, you've got to start by making it equal 0, just as if you were doing the null factor or quadratic formula. And then what we'd do is we'd just sub it in. So we'd go, all right, so we've got minus 7 squared. So I'm just taking that from, this pen's going all over the place today. I'm just taking that from this formula here. So I've got b squared minus 4 times a times c. So we'd end up with 49 minus 4, which would be 45 square root. And so this would be an example of an irrational number, okay? Because if we stuck that into the calculator, you'd get lots of decimals. So we'd end up with an irrational answer. And more importantly, we'd end up with 2, okay? So we'd end up with 2 irrational numbers as our answer. And you'd write that neatly. You wouldn't shorthand it like me, but I don't want this to go forever. A second example might be something like x squared plus 4x plus 3 equals nothing. Again, it has to equal nothing. If we sub this in, we'd get something along the lines of 4 squared minus 4 times 1 times 3. So we'd end up with something like 16 minus 12, which would give us the square root of 4, which we know is 2. So this would be an example of 2 rational numbers. The reason that there's 2, don't forget, is because if we were actually using the quadratic formula, it's plus or minus, okay? So there's going to be 2 possible rational numbers. It's going to be, whatever minus b is plus a rational number over the top of a fraction. So it'll give you a nice, neat fraction answer. Am I making sense if I say it like that? Another possible outcome might be something along the lines of a third one where we've got x squared plus 4x plus 5 equals nothing, which would give us 4 squared again, but this time minus 4 times 1 times 5. So what we'd end up with is we'd end up with 16 minus 20, so we'd end up with a minus, a square root of minus 4, which is an unreal number, okay? Or in our case is a no solution, okay? And that's where your computer or your calculator will throw up one of those syntax errors or maths errors at you. So if you hit that, you just double check it to make sure. But if it hits a no answer, it's because there's no solution. And the last one that you might get occasionally, there's not very many examples of these, would be if you got something like x squared plus 4x plus 4, because if you sub this in, you'll end up with 4 squared minus 4 times 1 times 4. So you'd end up with 16 minus 16, which is the square root of nothing, which is nothing, okay? Now, in this case, you have got a rational answer, but you've only got 1, okay? So this will lead itself to 1 rational answer. And I think that the potential answer, I can't spell while I'm talking. Okay, or 1 rational number is probably a better answer. And the reason for that is because don't forget, way back up here at that formula stage, you've still got that plus or minus there. If the square root, if under here, under the square root symbol is 0, then this is irrelevant, isn't it? You've still got just one number over another. So you'll end up with a rational answer, but there'll only be one of them. I'll stop this now.